So for part A, we're going to be using the equation of continuity. So the cross-sectional area of a pipe times the velocity of the fluid traveling through this pipe is going to equal the cross-sectional area of another section of the same pipe, and then times the velocity of the liquid through that specific cross-sectional area. They're saying initially we have a cross-sectional area of 0.07 meters squared, and then we have an initial velocity of 3.50 meters per second. It's asking us in part A, what would be the speed if the cross-sectional area of the pipe was reduced, or rather was increased to 0.105 meters squared. So we simply need to use this equation. This equation, isolating V sub 2, V sub 2 would simply equal the cross-sectional area of the first section times the velocity in the first section divided by the cross-sectional area of the second section. This solving for, we have 0.07 meters squared times 3.50 meters per second divided by the cross-sectional area in this second part, which is going to be 0.105 meters squared. At this point, we can use a calculator, and we know that the velocity in the second section of this pipe is going to be 2.33 meters per second. Now, part B is asking the exact same thing, except that the cross-sectional area, A3 we'll call it, is going to actually be 0.047 meters squared. So here, the cross-sectional area is actually decreasing. So again, we're going to use this equation, and we have that velocity in the third section is going to be equal to the cross-sectional area of the first section times the velocity of the liquid in the first section divided by the cross-sectional area of the third section. Plugging in for our constants, we have 0.07 meters squared. Once again, 3.50 meters per second divided by the cross-sectional area. And here, this is going to be 0.047 meters squared. So the velocity in this third section is going to be 5.21 meters per second. Now, the third part of this question is asking us, C is asking us how much, what's the volume of water after 1 hour. So the volume flow rate is going to be defined as the change in volume divided by the change in time equals the cross-sectional area of any section of the pipe times the velocity of that section. We'll use the first section, so we can use our subscripts here. And we're going to solve for delta V. So we should isolate this variable. Delta V is going to equal the cross-sectional area of section 1 times the velocity in section 1 times the change in time. Plugging in for our constants, we have, again, 0.07 meters squared, 3.50 meters per second, and then we have 1 hour, and then there are 3,600 seconds in every hour. Solving for this, we find that the volume is going to be 882 meters cubed. So this would be the volume of water, volume of water flowed through the pipe after 1 hour. And this is the final answer for part C. And that's the end of the solution. Thank you for watching.